Hey, this is Peter from Side Effects. I'm going to walk you through this follow-along lesson that's designed to be used in a classroom or a lab setting. The goal of this video is to help you understand the why behind these steps in order to help with comprehension of these concepts. Also, I want to help you identify any pitfalls that you might face or your students might face along the way. This will be a very casual conversation, so don't be surprised if this example doesn't match 100% with the files given, since I'm going to be rebuilding this live with you as we kind of go through it. So with that all being said, let's jump in and start the lesson. All right, so the first thing that we're going to do is set up our project directory. And this is really important because it's a step that tells Houdini where to find files on disk that we might be interested in. Kind of gives us some quick variables that we can use. You'll see that in some of the file paths. There'll be things like $job, $hip. And this is a just real easy way for the software to know where we're sort of looking on disk for our, say, geometry or our HIP files, our project files. So that's the first thing we'll do. So let's go under File, Set Project, and we're going to navigate to the location on disk. Now you will probably have a different location because you'll be unzipping some files that you've been given by us. I've set up sort of a similar file path. It's just on my desktop. So I'm just going to go to Desktop, CIB, and CIB lesson 1 and hit accept. Now it doesn't seem like anything actually happened there, but we're going to go to edit, aliases and variables. And here we can look at our variables and we can see that now our job variable has been set to that location. And that's really important. That kind of is going to tell Houdini where this location is, and we can just write $job and it'll resolve to that exact location. Now this isn't something super important for us to tell our students, but it's good to just kind of give them an idea of that we're saving these variables to use so that Houdini knows, we don't even have to really tell them that they're variables. We're just saving this information so Houdini knows how to find these locations on disk, and it can then use that to more quickly find, our geometry files or our HIP files or things like that. So that's just for you to kind of understand what's going on behind the scenes. But for our students, it's easier just to give them a little bit of a more basic understanding. The next thing we'll do is we're just going to save our scene files. So we'll save this as, and I've got a few scene files in here. These are ones that you'll have from the zip files that we're giving out, but I'm just going to make a new one in here and just say, let's play with Houdini. And this is live. So I'll just say live and we save that out. And now if we look in that same spot, we can see that our HIP and HIP file variables are set. And we also have a HIP name variable in here as well. So those are all things that we can use when we're making file paths and things like that. We won't do a ton of that here, but it's just good to know for your own sake as you're kind of getting more and more familiar maybe with Houdini or starting off. Just good to know what these things are doing. So. All right, so we have those things set up. Let's talk a quick bit about what the workspace is that we're going to be working in here. So there's kind of 5 main parts of this that we can look at. The main viewing area is the scene view here. This is really important because obviously this is our 3D viewport. This is where we can see kind of everything that's going on with our geometry and eventually the simulation work that we'll be doing in this exercise. There's also the parameter pane that's up here. You'll see this described in some of the step-by-step walkthrough that I'll call this the parameter pane. And down here we have our network view. This is where we'll be actually placing our nodes. So this is where our nodes will go down here, and this is where the parameters for those nodes will be displayed. Now you can set these desktops up however you want. I'm just using the standard build desktop. You can see that there's a whole list of them up here. You can save your own. I have a few custom ones that I've saved over my time working in Houdini. But I'm just sticking with the main build one just so that it's visually the same as what you'll be using and what your students will be using so that you can more easily get kind of familiar with that look. And so the other thing, we have our shelves up here. We won't be using those too much really in these lessons. We want to get a little bit more hands-on feel with the nodes and where they get placed and things like that versus just using the shelf tools to place them for us. Those are great shortcuts if you want to do things, but we're mainly going to be typing and dropping nodes down in the more kind of traditional way that I like to kind of get that hands-on feel. And then finally, we have down here the play bar. We'll be using this once we get our simulation going. There isn't really anything happening here, right? When we click and drag, that's just moving the playhead. And we can also hit play here. Now this is going crazy fast, and that's because we don't have a real-time toggle on. And if we turn that on and now hit play, we should be all set. So these are just some of the parts of the interface that you'll see me using here throughout this walkthrough. But there's obviously more elements and pieces, and you can set these up kind of to your heart's content. So that's just something to keep in mind as we're kind of walking through here. So let's move on to the next step, which is to actually make a place where we can save some geometry. So let's hit tab and type in geo, and we're going to see that geometry has now come up in our tab menu, and that's what we want to make. We want to make a geometry object. So we're going to click and place this node. Now, the best way to kind of describe this to your students is we've now made a container for our geometry, right? This is sort of like a folder in a file system too, where we can have this address where these things are going to live. If we double click on this, you'll see that the address changes and we're now inside of this geometry one. And when we click here, we go back up to object. This is just sort of a way to think about these things, right? We're containing our geometry in an object, right? We're at the object level here. And this is a way to kind of organize our scene, organize what we're doing. We're going to make a few different things at the object level, but for right now, our geometry one, this geometry object will be the main thing that we'll be working on for the time being. So we clicked to place that node, and let's double click on the name. We can change this to something like particle fun. And this is now we've named this, so it's got a custom name. It's not just some random geo1. And this gives us a bit more understanding of what's going to be happening here. We're making some particles. We're also going to be playing around a little bit. So best to name your geometry objects or name your objects in general, just so you know what it is that you're working on. It's best practice, just good to get used to. So let's now dive inside. And we're going to import a file from disk. So let's type, we're going to just click in the, or be in the network. We're going to hit tab and we're going to hit file. And we're going to type in file. We're going to see it come up in our tab menu. And this is kind of the repetition that we want students to be able to get, is that you hit tab over this, you select something, hit enter when you've got it selected, and you can click to drop it down. And we get a file node here. So we've clicked to place our node in the network. We have this file one node. You can see this kind of default geometry. You can see that actually is a piece of geometry. This is default.bgeo. These BGEO files are just Houdini's default file format. So that's something that we use just to store our geometry. That's kind of our own custom file format. You can use other types of geometry with these file nodes. It's just that we are going to be using, Houdini specific geometry here. So we have our file node. Now let's select something specific that we want to import. So we're going to use the this little floating file chooser button. We're going to click on that. And again, we've now opened up into that same directory that we had set up before. So now we can see that there will be a geo folder in here. So we can click on that. We can go in here, and I'm also going to uncheck this little toggle right here that says show sequences as one entry. What that does is basically looks to see if there's like something that looks like a file path that has multiple maybe frames or multiple versions or whatever, and it'll try to put them into some sort of a sequence with time. That's why you see these little $Fs here. That's a variable like we were talking about before, but one that actually tells us what frame we're on currently. So we're going to uncheck that because we don't want, these aren't, frame specific. They're not animation. So we're just going to go back to this. And these are all different assets that your students could bring in that we've supplied for you. These are from a project called the Magic Market. It's from our content library, and you can kind of look through all of these and find something that you might want to use for your, for our simulation or to play around with here. So we can maybe select something like the bucket here, bucket with rope handle, something like that, and hit accept. And now you can see we have some geometry in our scene. And we can tumble around. I primarily do that by holding down Alt and clicking, left clicking, but you can also do that with space to bring up the view tool as well. So there are a few different ways that you can do this. I'm just used to the Alt key. You can use space as well to do the same thing. So this is how we bring geometry in and kind of manipulate it and work with it. Your students, you should probably let them feel free to kind of play around and find as many, find some interesting geometry, something that they really like. Maybe grab one of the books, see what that looks like. Okay, we got this kind of interesting little flat book here. Maybe a large basket with carpets. What does that look like? Okay, it's a way different one. It's got some interesting things, and give them the sense that they can play around and find some interesting things here that they might want to use for their, exploration in this lesson. The one that I'm going to finally go with is the barrel with no lid. We'll do that one. That's what I used in the rest of the example, that document that I have given with this lesson. But, like I said, feel free to have your students choose whichever one they want. I'm just going to go with this one just because it's in the examples. And the last thing that we want to do in this part one of our of this kind of exercise is we want to position the geometry properly in our scene. Now, it's positioned fine, but we want to sort of regulate the size and normalize the size to something so that no matter what type of geometry the student's using, it's going to have similar controls when we add things like wind and variability to the simulation. Sort of an important thing to do. So we're going to use a match size node for that. There's a few different ways that you can add another node in here. You can click on the output dot here to get this little wire. Then you can type match and then match size like that. We can just kind of move this around. You'll see it snaps as we move it. It's just something important to kind of tell your students that your nodes will snap to each other, and you can kind of organize as you would like with that. The other thing that you could do is you could right click on this and type match size and type enter. And then there you go. We've got that node, and I'm left clicking to place that down. There is one other way that you might see me do it, is just without clicking anything, you can hit tab and do match size. Now, this creates this little kind of ghosted node, and I have to move it close to get this little connecting line to drop that in. Like I said, there's many different ways that you can do this. It's not super important that you do one thing or the other. It's just an understanding of what you find easiest to teach your students. In a lot of these, I will I'll say, click this output dot, press tab, type it in, and then click to place it. You know, that's sort of the standard way of doing this. So you can do it however, any of those ways. You'll see me actually probably type without clicking on anything first. So there might be times when you'll see me do that. I just wanted to make sure that you're aware of the different ways that you can place nodes down in Houdini. There's often many different ways of doing something. So there is no always one right answer. There's often a few. So just something to keep in mind. So now we have this match size, and what we're gonna do a couple things with it. First of all, we want to make sure our display flag is on our match size. That's always super important, because as we change our display flag, that'll show what's viewed in the viewport, right? And the other thing we want to do is change our justify Y. We want to set that to min. And what that means is the minimum Y position, we want to justify that on the 0 of the Y axis. So that's what we're doing right now. So now it's kind of sitting on this grid here. Now, the other thing we want to do is set scale to fit. And we want to make sure that we have our object scaling to 1 by 1 by 1. So that's this blue box that we're seeing here. Obviously, we could change this, scale it a little bit higher or lower, but 1 by 1 should just be fine. And that will that'll sort of make sure that all of our geometry, no matter what it is that we put in there, will be roughly scaled to the same size. For example, and you don't have to do this with your students, but you can bring it in here and say, okay, let's grab that large basket with carpets and see what happens there. And now between these two, you can see that it scaled it and made sure it's the right size. Maybe we can grab something else here, like the handles. Let's see what that is. So now this is actually probably scaled up a bit to match into that 1 by 1 size. So this is just basically normalizing all of our geometry to be in that same space, so that as we're making adjustments and things like that down the line, all of the geometry that we're adjusting should more or less act the same when we add wind and things like that to our simulations. It's really more about that step. So this concludes the end of section 1, part 1 of this walkthrough. And in the next section, we're going to start adding some particles and doing some of the simulation work that we've talked about. All right, so for part 2, let's start adding some particles to this, simulation, start getting things going here and making some interesting stuff. So what we're going to do is we are going to add a PopNet. That's a network that will allow us to have a particle simulation in Houdini. Now, it's not super important to get into all the details of what this PopNet is and what's inside of it. We'll touch on a few little things here and there, but this is basically just a quick way to add particles that emit from the geometry that are coming into the network. That's kind of the most important thing to say here, is whatever you put in, it's going to be the source object that where those particles are going to emit from. So each student, when they choose different things, will have slightly different simulations based on what object they choose. So that's why we want to give them some freedom to be able to choose some different things here. So let's click on this. We'll hit tab. We'll do pop, and pop network will come up first. And there we go. We get that in our scene, and we'll go to this. And now you'll see that we're starting to get particles that are sourced on this geometry. Another interesting thing that you might want to do or show your students, which you don't have to, you could use this little template flag and that will show kind of the geometry at that stage in the network. And it'll show it kind of as this like ghosted wireframe. So that could be helpful to kind of let students understand what's happening, that these points are all located on the actual geometry. Not so totally necessary. You can do that kind of as you wish, but hopefully that might give them a little bit better sense of what happens. So again, we have our timeline down here. We can start messing around with this. Make sure that your clock is checked so that this will play back in real time, and we'll hit play. And we'll see that now there's particles being added to this simulation. But it's not super interesting at this point. It's basically just particles being added onto the surface, and nothing's really happening here. So let's go inside of our pop network and kind of manipulate how these particles are moving around. And before we do that, one real interesting thing here that you might want to just note is that this blue line right here tells you where your cache is. Basically, it's going to save that simulation into your computer's RAM, and once you have it saved there, you can kind of easily scrub around and see this without having to recalculate it. Just kind of keeps an existing just pass of this simulation in memory so that you can freely scrub around. So that's something just to keep a note. So let's dive into this PopNet and see what's going on in here. So these are the nodes that make up a particle simulation. We don't really have to worry too much about this, but you can just kind of quickly go over this, that there's a pop object here where the particles are going to live. We have a sourcing node here, and we have this solver. That's kind of where all the brains of the operation are happening. But one important thing is we can wire other pop nodes into this merge right here. So if we move this over, we can see that if we wire other things in here, this is going to help us manipulate this. So that's kind of where we do all our manipulation, is in this merge node here, where we wire things in to do different stuff. So we're sourcing, but maybe we want to add some wind. So let's do that. Let's go down and add a wind force here. So we're going to hit tab, and I'm going to do a pop wind. We're going to click to place that, and I'm going to click on this output and into the top of the merge here. And now we have a pop wind that's moving into that merge node. So let's really quickly maybe hit play and just see what's happening here. And we should see, well, nothing really happening yet. And that's because we haven't changed any of our parameters. Another thing to note too, that this blue line here, this line view that we're seeing is from our pop source node. So if we want to hide that, we can go into our source and we can hide the guides there. So it's up to you if you want to have them on or off. I think I'm going to turn them off for mine. Might be just a little easier to see, but you can keep them on if that helps you as well. So that's up to you how you feel like visualizing this best. But let's now go into our parameters of our pop wind. So we'll click on that, and we can adjust the noise amplitude here. That's what's going to start pushing these around like a wind force, basically. So let's set our amplitude to 0.5. This will give us a little bit of wind noise, but not a crazy amount. And it'll start moving them around. And the other thing that we might want to do is check this guide parameter. And what this can do is actually show you where the guides are, or where the velocities are in your simulation. So let's hit play and see what happens here. And now we can see that these guides are kind of showing us where the direction that this wind is kind of whipping around in throughout the space of our simulation. Now it's only showing it for this ground kind of grid plane, but it still gives you an idea for how quickly it's moving and things like that. So now we're starting to see some particle simulations that are pushing these particles around in our scene and adding this noise and this velocity. So now we're starting to get something that's quite a bit more interesting. And again, we can scrub back and forth here to see what's happening. So we've run our simulation. We've kind of started to see, okay, this is how simulations work in Houdini. We've got this little network, and we're going to add some nodes, and those are going to make some modifications to the simulation environment. So the next thing that we want to do here is go back and add an output node for our particle simulation. And this is important because it's going to kind of tell this object that we've got this contained in where the kind of final location of our geometry is. So we'll go back up and do this now. So we've got this set up in here. We've got some wind blowing this around. Let's come back up here, and we're going to click on this. We're going to hit tab, type out, and we'll see output come up there, and I'm going to hit enter. And now we have an output node. And like I said, this is going to sort of tell our object, our particle fun object, where to source the geometry from, right? So if we come back up here, we just have this object. So what's going to show at this level, or maybe when we're rendering, what is going to be the output of it? So that overrides anything like this blue display flag here. It'll always show what's in there. So if we come back up here to match size and then come up a level, you'll see that we still are seeing those particles because that's what's being output at this output 0. So it's an important little piece to get to kind of pay attention to and make sure you understand. But yeah, it's a very simple little thing. And another tutorials and things like that online, you might see people use nulls, and those are great too. But in this case, we just want to make sure we're forcing the output to sort of stay where it is. Okay, so now that we have our output node added in there, we're going to get to kind of the last section of this part of our lesson. And this is going to be adding some colors to these particles just to make it a little bit more interesting so we can see how this works in Houdini, how adding some colors into this will kind of add some visual interest. So what we're going to do is actually add colors before our pop network here. So I am going to hit tab and type in attribute adjust color. So attribute adjust color, and we're gonna hit enter. Now we get this little ghosted node, and we're gonna drop this in between here. And so what this is going to do is give us some parameters to adjust the colors of our geometry. And the thing that's really important for students to understand here is that we're adjusting the color on the input geometry, not the particles themselves. So this is taking the geometry and adding a color to it. Now you can't see that here because we haven't really added any colors to it. But let's go into our pop network, and you can see that these are white, right? So now these particles are white. So we're seeing that at this stage that we have white particles now. So we've added a white color as attribute adjust color is set to white. So let's now go from setting just a constant value to adding some noise to this. So let's take the pattern type, change it to noise. And now we're going to start adding colors here. This is kind of the default color ramp, and if we hit play here, we'll see that there's going to be, these particles are going to be emitted with those colors. Now those colors aren't really changing over the geometry, so any particle that is sourced from this geometry in any of these specific locations will always be getting the same color. So here we can go back up and see that, okay, our original geometry is now colored, and if we hit play, nothing really changes here. So let's do something to change the colors of this, because I think this is maybe a little too bright. Let's make this a little bit less like vibrant and intense. So what we can do is we can actually select a bunch of different color ramps that we have as presets. We can use this little gear icon and find a whole bunch of listed options here. The one that I'm going to use is this Viridis. I just think it's kind of nice. It's got some darks and some lights in there, but you can use whatever one you'd want. You can encourage your students to look at any of those that you might be interested in, but those are all right in this gear icon here. You can also make your own custom color ramp, but that might be a little bit too advanced for students that are just getting out with Houdini. It might be better to just stick with presets and kind of guide them slowly through the process here. So we've changed the pattern to noise. We have a color ramp set. Let's now do some animation to the noise. So we can scroll down a little bit here. We can go and open this animation, kind of drop down arrow. And in here, you can see that there's an animate noise button. And we also have now a pulse duration that's come up. And this is just basically our speed. That's all this is just the speed of it. So if we hit play right now, we'll see that it's kind of moving pretty frenetic, honestly. It's a little fast. So if we do pulse duration and set it to 2, that's basically how long it takes for it to sort of loop through the animation of this. So now it's going to be a little bit slower. It's going to basically take 2 seconds instead of 1 to sort of go through its noise animation. So now we have this animating. And if we go down here to our pop network and hit play, we'll see that these colors are going to be kind of changing and sourcing differently over time. So now some of them will be light in certain colors and dark in others, and then that'll switch around over time throughout this simulation. But what I think is even maybe a little bit better to visualize this is to make the color of the noise, or the size of the noise, a little bit bigger so that the color is more uniform across the geometry, and that way you can see it a little bit more clearly as it's changing, because over time then you'll see that color sort of change on the entire geometry. So how we can do that is we can go into our element size. And if we visualize this, we'll see as we change the element size, we get a more or less uniform noise across the geometry. So what I'm going to do is I'm going to bring this all the way up to 10. And this should be almost completely uniform across the geometry. You'll see there's a little bit of difference, but now as we hit play, the whole thing's going to sort of change color in a more uniform manner, and we're all going to have sort of the same particle colors being emitted from this geometry over time. So now as we see the different particles, we know that those are from sort of different moments in time throughout this simulation. So let's go to our PopNet. We'll see that they're all yellow right now. And as we hit play, they're going to sort of slowly change over time, be a little less frenetic and noisy, and just give us a bit of a sense of when in time these particles are sort of coming from as they are sourced in different color shades as we go. So now we have this nice size there, and you can sort of change that however you'd like. Maybe you want it more or less, but these are sort of things that we want to introduce students to so that they understand a bit better of how these colors can sort of be passed through the nodes into the further nodes in the chain. And the important thing to note here is that we are creating an attribute, and that's something that's super important in Houdini. But we don't want to really start talking about that at this stage of our kind of learning journey. We want students to just get a little bit more used to the idea of, okay, I'm doing this, then I do this, then I do this, and this happens, versus getting into all the weeds of, okay, this is what attributes are, and we made a vector color attribute and all this type of thing. It's a little bit better just to get a sense of how the program works first before you dive into some of those deeper concepts. We will get into that in a future curriculum in a box lesson, but for right now, we're just going to stick with, we're just adding a color to this geometry. We're not even talking about where we're adding it to or anything like that. So this is just kind of the basic introduction to doing something like this with color. So that will wrap up part 2 of this lesson. If your students are struggling to follow along with any of these parts, I have made files for you to hand out to them so they can open that part 2 up, and it'll be exactly where we are at the end of this this lesson at this point. So feel free to use those, hand them out to your students, and they should be able to kind of catch back up to where you are without having to sit down and troubleshoot maybe what they may have done wrong. It just gives you a nice place to kind of reset, group everybody back together, and continue on. So in the next section, we're going to talk a little bit more about rendering an image. For the last part of this lesson's guided work, we want to talk a little bit about how you render an image in Houdini. This is obviously something that students really like and get excited for. I think it's really interesting to see sort of the end result of what you made as something that feels a little bit more real than just particles on screen moving around. So that's what it is that we're going to try to render here, is render our particles as spheres, maybe add some materials and some lights to it, and just get an overall sense of how this whole workflow goes kind of from start to finish. So what we're going to do first is we're going to move over to Solaris, to the Solaris stage. And what we can do here is we can just right click on our network bar here. And this is where Houdini sort of mirrors a file system in some ways, where we have these different contexts, which are almost like different folder locations that we can move to. Each of these different contexts are used in various ways, but our stage is where we now do most of our rendering. So what we're going to do is we right click there, we come down to stage, and we click on that. And now we've moved over to the Solaris stage. And the reason that this is called stage is a very complicated one. It has to do with some of the underlying technology that's used within Solaris. But I think the best thing to think about here is that we can think of the stage, talk about what a stage is, right? A stage has lights, it has cameras, maybe it has, it's a place where you lay things out in some sort of a scene. That's what Solaris is really used for. That is the idea for Solaris and what its main purpose is within Houdini. You can very easily see that we're here because our network now says Solaris, and this is going to give us some new nodes, and we'll kind of walk through some of the basics of how to bring those things in. So what we're going to do first is we're going to bring our objects to the stage. Now this is where that kind of really important object that we created is going to go. So we're going to hit tab and do a scene import. and we're going to do scene import all. So we're going to click on that and drop it down. And what you'll see now is all of the geometry that we had made in our object over in our Solaris context. And what this means basically is we've now imported that into this to be able to be ready for rendering. And so now we've got our geometry in here. It's kind of step one in this process. And this scene import all will bring any objects that we had in our object context over into Solaris. So if we had 10 objects, it would bring in 10 different pieces of geometry. Now there is a way to view that, and it's in our geometry spreadsheet where we'd be able to find that, but we don't want to really overly complicate things for our students just yet. We just want to make this really simple so they can start to understand, okay, we just import it into Solaris and we start doing things with it there. The more complicated stuff can come at a later date, but for now, this I think is just an important way to show them, hey, here's a quick way to be able to render something. So we have our objects on the stage. Let's now add a light to start doing something a bit more interesting with this. So what we're going to do is we're going to click on that and we're going to do type physical, and we're going to use a Karma physical sky. And so this physical sky sort of represents the way that the atmosphere looks and the direction of light from the sun. You can see that we have an altitude and an azimuth. This basically rotates the sun around in an angle as we move this parameter here back and forth. You can also change the altitude, which will adjust how high the sun is in the sky with this control here. So I'll just reset that back to defaults. So you can play around with that, get different sun angles, and it sort of changes the whole look and mood of the scene as you move that around. Creates like sunset looks and things like that. So you can get a very different sense of how things are. So if you don't want to see these icons in the scene view, you can click on this right here, and it'll turn the icons off. Just a way to kind of clean up your scene a little bit. The other thing, since we're on the stage, we might want to have a camera in here. So what we can do is we can move this around to someplace that we maybe find interesting. Maybe like that. And what we can do is while we're in the scene view, we can hit tab and type camera. And it's important to do this in the scene view and not in the network view, because this is going to kind of create a camera from the location that we're in right now. And if we hit enter, we'll see that nothing has moved in the scene view, but it's added a camera in there. So this is an important sort of differentiation to make for students, that if you do things in the scene view like that, where you hit tab and type something in, it often will do something a little bit different than if you hit the tab key and then type something in the network view. In the network view, it's really just going to add a node for you. In the scene view, it might do things like this, where it's going to keep you in this one location when it adds the camera, so that it adds in all this information. You can see the parameters have been updated to the exact location and space that we're at and the rotation. Just an easier way to do things. And as we go through some more lessons, we'll see more and more of that kind of added in. In the next lesson, when we're manipulating geometry especially, you'll see a lot of these in viewport type of manipulations done. And it's a really important thing, I think, to get students used to that. So we have our camera set up here. If we wanted to move this around though, say we didn't like where this is, there is a way in the viewport to just make sure we can move the camera around. Because if we just hit Alt or space and moved around, you'll see that we've now kind of exited the camera and the camera exists right there. So that's not super helpful, right? We're going to want to probably move this camera at some point. So what we can do is we can go back to our camera. There's a little drop down here. We can hit camera 1, and this will bring us back into that camera we just created. So how do we make sure when we move, we don't move out of that camera? Well, we hit this lock right here, and this will now keep our camera in that position as we move around. So as we tumble around in our scene, that'll keep our camera sort of locked to the view. And again, you get this nice red hint here that shows, okay, we're locked in. So just know that anytime you move your scene view, your camera is going to move along with it. So once you get to the point of knowing you like, your camera position, you'll probably want to unlock that so that you don't accidentally move it in the future. So just an important little note to understand there. So again, as we move through this here, we can see that the time import has worked. We've got all of our animation here. I'm going to, for this render, maybe keep it at around frame 120. And that's just sort of a nice spot where the noise has started to sort of move around, but it hasn't done anything too crazy. And if we go back here, we can maybe look through our camera, and maybe I want to even get in a little bit closer now that we've framed it that way. We can just scoot it in a little bit more, hit lock again, and now we've got it locked in place. So the next step that we want to do is we want to actually see what a rendered version of this scene looks like. So how we can do that is we can go into this little drop down here next to our camera menu. And here you can see that we have a few different options here with these little radio buttons. And the three that we're going to be interested in are the Houdini VK, which is our viewport, standard viewport, and the two different Karma types. Now there is also Storm. That comes default with USD, which is one of the underlying technologies of Solaris, but we're not really going to worry about that in this example. You can take a look at it if you'd like, but right now we're going to stick to the Vulkan viewport, Houdini VK, and the Karma viewports. So if in your school you have a NVIDIA graphics card and a recent one, maybe a 2000 series or later, I would recommend giving the Karma XPU a shot because it's going to be a lot faster to render and it's just going to be a little bit snappier overall. Now, if you don't have an NVIDIA graphics card or a more recent one, you would use the CPU version, which is just going to run only on the CPU of your computer. XPU uses both the graphics card and the CPU. So that's kind of up to you. And what we can do is we can really quickly render this out and see what it looks like. So now your scene may look like this or it may not. This is really depending on the current version of Houdini that you're using. So this is a little bit of a gotcha here. In the scene import setting here, there is this option called set missing widths. And if we turn that on, we'll see that it looks like this. So if you're seeing this in the viewport, that means that this is probably turned on. This was enabled at some point in the more recent Houdini versions. And so the example kind of goes with this as an assumed setting. But to turn it off, you just go into the geometry handling here and change this checkbox here. And that just basically changes the width of those particles. And you could set it to something else if you'd like to. So if you'd like to come in here and just adjust this a little bit, you can manipulate this however you might be interested in doing. So that's possible. You could have your students play around with that, see if there's a size that they like or whatever. But right now I'm just going to turn that off and let it be the default value of 1. So you will see that a little error pops up here and it just basically says with data points not found, USD default value of 1 will be used. So that's all that is. But you can see now that we're seeing a rendered version of our scene here with the colors and the shading and everything like that in the viewport. So the one thing I notice when I first see this is that it looks maybe a little bit dark. So what we should do is probably adjust the exposure of our light. So what we can do is we can come down to our Karma Physical Sky here and go to the exposure. And you can see here, if we adjust this, it's going to adjust the brightness in the scene and it'll take a second, it'll snap in, there we go. And so what I thought was a value maybe around 2 felt good. Feels like it's bright enough, feels like we're getting kind of the right exposure now. And you can adjust that obviously as you may see fit, but that's the way I'm going to leave it right now. So we have our scene, we have our light, we have a camera in the scene. Now, maybe instead of just going with these colored spheres, let's try adding a material to this. And this really gives your students an idea of how this workflow might go. So what I'm going to do is I'm going to turn off the viewport here, just so we're not having to render every single update that we put in. And what we're going to do is we're going to add a thing called material linker. So let's go here, hit tab, do material, and then material linker. There we go. And now we have a material linker in our network view. And what this node does is gives us access to an entire catalog. And so what we can do is we can go into this tab right here and go to catalog. We can also move this over here and just see the catalog itself. And what we're going to want to do here is make sure that our geometry tree is open here. So you can see this little plus. So yours might look like this. It might look like this depending on how it opens up. But now we can see all of our different objects here. And we can see the object particle fund that we brought in. So that is going to be where we want to assign our material. So let's grab a material. What I found was one of the metals was kind of interesting. So let's grab the metal bronze here and drag and drop it onto the particle fund. You won't see anything really change in the viewport, but let's go and now let's render it and see what happens here. And sure enough, you can now see that there's this shiny metallic material that has been applied to this. So now we can sort of see the workflow for how we might apply a material here. We can use the material linker for a nice catalog of materials. Now, obviously in Houdini, you can build much more complicated materials than these defaults. However, I think for new students, this is a really nice way to be able to just start to experience and experiment a little bit with adding materials and shaders and things like that to your renders. So this is a pretty straightforward way of doing things. So now that we have this sort of rendering in our view here, let's give it a second. We'll let it kind of finish up. You can see that there's a render percentage up here. We're getting pretty close to the end. And what we're going to do is we're going to take a snapshot of this scene and save it out to disk. So what we can do is we can come down here to our little snapshot strip. We can click on that. That'll bring up a new part of the menu, and we'll see that we have this kind of blank area, and this is where we can save snapshots of our scene. So what we'll do is we'll come down to the snap button here, the snapshot button, and we'll click that. And now we've created a snapshot of this scene. Now it's also taken a snapshot of our network here in Solaris. So that's kind of an interesting side effect of doing this. But really what we're mostly interested in here is just taking a quick render of our scene. So we have our snapshot. Now what can we do? How can we save this to disk? So what we're going to do is we're going to double click this and we're going to open it in the render gallery. So now this is kind of a similar view to what we have in our scene here, except it's showing the render here instead of our viewport. So what we can do then is, now that we have this render gallery up, we can right click on it and click Save Frame. And you can see up here that we have a file name in the top. And what we want to do is change this to something, something that means a little bit more to us. So why don't we change this to something like My Particle Render? And we'll do that. My Particle Render, like that. And it's an EXR right now. And instead of that, let's change it to a PNG. That's a little bit more of a familiar file type, hopefully for most people. What you'll see is when we change the extension here, this UI changes a little bit because it has different settings based on what the extension is. You can see right here, it says infer from file extension. That just means look at the file extension and adjust the settings as needed. So we have that all taken care of, and let's hit save. And now what we should do is be able to go and see what this actual final rendered image looks like. So the render's all finished. Everything's good. I'm going to minimize this. We're going to go to render. We're going to say preview. Go to mplay and go load disk files. This brings up our load image. And now we can see here, since we're still in this hip folder, we can see we have My Particle Render, and I can hit load and we'll bring up this actual finished render that we did here. And so this is going to conclude this first lesson that we bring our students through into Houdini. Hopefully it'll give them a really great kind of overall snapshot view of what Houdini looks like when you go kind of from start to finish in the process. And in the coming lessons, we will continue to kind of refine this. But maybe this is going to be the only lesson that you're going to be able to do just to give your students a little introduction to Houdini. And for that, we obviously thank you. And we think that this will be a really great way for them to see what Houdini is capable of, and maybe even just get a new sense of what they can do with simulation and rendering and effects and things like that. So thanks for watching, and maybe I'll see you in the next lesson. Thank you so much.